I'm really looking forward to the next slot we will hear now, because now it's the time of Sparkfun. SPE on Sparkfun, maker scene on fire with SPE. So this is also a really cool success story, which will now be brought to us by Joachim. So you saw Joachim already on stage on Tuesday. Welcome back, Joachim.
Yeah, thanks.
And Kirk from Sparkfun, who will let you know what you can do with the Sparkfun development board to set up your first applications with SPE. Stage is yours, Joachim.
Okay, yeah, many thanks, Kilian. So SPE, as we have heard, is a very, very interesting and promising technology. From what I see at our customers is that a lot of designs are actually taking place. So if you do, for example, go on the SPS last year, end of last year, it was that you saw a lot of connectivity, a lot of devices, but you did not, but not too many devices, yeah, that's the case. But behind the scenes, all the different companies, they are really developing and working on new projects, new devices where this technology is already being integrated. Yeah? And what we as HARTING thought is, okay, how, besides this, how can we enable also smaller and mid-sized companies to experiment with the technology, to try it out, and to make use of it in a very easy and cheap way. And what we did is we, together with two partners, so Analog Devices, Würth and HARTING, those partners provide all the components you need to develop an SPE-based device, so the connector, the magnetics, as well as the chipsets. And together with those two companies, together with Sparkfun, so really a company who is specialized on developing boards, development boards, and integrate new technologies. This is the third partner. And we needed a kind of a promotion channel, so we did this with DigiKey, means that the availability globally is given. And what we did is the following. So we developed, or Sparkfun developed a development kit for SPE, where it's very easy to use and play around with the technology. And due to the time difference, so Sparkfun is based in the US, we have taped and recorded the next session. And yeah, so Kirk Benell, he will introduce, on the one hand side, the Sparkfun ecosystem, MicroMod. He will introduce how they enable companies to play with new technologies. And then in a third step, he will deal in detail about the new SPE kit to play around with the SPE technology. So now I would say, please play the Sparkfun video.
Thank you. I'm Kirk Benell, CTO of Sparkfun Electronics in Boulder, Colorado. Due to the time difference between Europe and Boulder, today I'm going to talk to you via recorded session. Hopefully we can cover all your answers and really outline what we've done to support single pair Ethernet, working together with our partners, Analog Devices and HARTING. For those of you who don't know Sparkfun, we're a small company just outside of Boulder, Colorado. We're just reached our 20th anniversary, so established in 2003. We actually design and manufacture electronic tools, so development boards and other products that accelerate prototyping and research and development. So we like to take a new technology, an interesting technology, place it on a development board, put it together as a kit, develop content, software, and bring that to our partners and engineering customers to allow them to really accelerate the research they're doing and to solve a certain problem. We really make experimenting with the latest technology easy and expand access to a wider market to some of these more key technologies available today. And we're always bringing in new technologies and capabilities into our ecosystem and working with key partners like HARTING to develop solutions to meet their customers' needs. You'll see here on the screen, we have a picture of our office. Again, this is just outside of Boulder, Colorado. Today it's snowing, so it looks a little different, but you kind of get an idea of where we are. And also note that this is where we do everything. So this is where we actually design, market, and build and manufacture our products, as well as ship them. So when you buy from our web store, the products will ship from this office here and ship to our customers. Now, one of the key areas that we do to bring these solutions to our customers is integrate capabilities into different ecosystems to make it easy to understand and plug and play. One of our more successful ecosystems is the Quick ecosystem. This is based on the I2C bus technology. It's been around for many, many years, but we standardized it with a common JST connector and a common cable. So again, you can plug and play your boards together, different sensors, different displays, different input devices, and the different microcontroller boards that have quick connectors. And this has been quite successful. You can hear here's just a small sampling of the solutions we provide. You know, this slide's actually a little out of date. We're up to 400 products instead of 150 that support Quick, and this is from microprocessor boards. You know, we actually support Raspberry Pi connectivity and hats for small single board computers. Sensors, a wide variety of sensors, from accelerometers, magnetometers, GNSS or GPS, environmental sensors, distance measurement, movement, imaging, really any sensor that's available, we try to bring it in the Quick ecosystem. And this is input devices such as buttons and joysticks, output devices such as LCD displays, OLED displays. We'll bring these into kits. And it goes beyond just the hardware, as you see on the screen here, but also includes software and documentation. So a key part of our Quick ecosystem is the abstraction we've done in the software, such that the engineer no longer has to worry about I2C low-level programming, and we abstract that into methods and objects within software to make it easy to call and easy to use. And additionally, our software includes examples to make it really easy to go from getting a board, connecting it, and getting results within a matter of minutes. You know, our target is 15 minutes with these new boards. But Quick's a big system for us and a big ecosystem. And as we develop new products, we like to bring them into an ecosystem that our customers are familiar with. An additional ecosystem we have is called MicroMod. Some solutions require high-speed communication, so beyond I2C, and this might be UARTs or SPI. And so we've developed a system called MicroMod based on the M.2 connector. And our initial deployment of this was putting processors on what we call a MicroMod processor board, which is again based on M.2. And then we put those into carrier boards that do specific functions, specific use cases that allow customers to experiment and try different things. Now we launched this, I believe, 3 years ago. We have data logging, machine learning, weather, an input-output display, and just a general dev board. And again, you can plug and play different processors into this system. So here's an example of what we launched with and the different processors we have available. Artemis, which is based on Apollo 3 microprocessor. Teensy, RP2040 from Raspberry Pi, the SAMD51, the NRF 52840 from Nordic, ESP32, and the STM32. So again, you can plug and play different processors with different, what we call carrier boards, development boards. And here's a selection we launched with. And also on the bottom, we have a couple of carrier boards, so you can plug in processors. And then we have mounting holes for different Quick boards, which have a common layout. So you can actually build and prototype nice looking solutions quickly using Quick and MicroMod. And again, this has been out for about 2 to 3 years. And the next evolution of MicroMod is something called function boards. And really a function board is focused at capability that does require high-speed communication, either through SPI or UART. And we wanted to really bring those together quickly and but generically, so you can kind of plug and play and mix and match, similar to what you might see in an old-fashioned motherboard in a computer, a desktop computer. This kind of brings that basic concept, similar concept at a high level into our MicroMod ecosystem. And you can see we have two what we call main boards, and these are at the top of the slide here. We have a single, where you can plug in a single MicroMod function board and a processor, and then a double, which you can actually do 2 MicroMod function boards and a processor. And both of these main boards also have quick connectors, so you can connect to our Quick ecosystem. You have access for SD cards, and it really allows you to rapidly prototype different solutions whether sensor solutions, processor solutions, communication technology. It really gives a flexibility to our customers and users to build solutions quickly. And at the bottom here is actually some of the different function boards we have available to give you an idea of how you can use these capabilities to build solutions. We have different Wi-Fi solutions, a LoRa solution, environmental sensors, different GNSS or GPS solutions based on U-Blocks modules. So one's RTK, which is high precision, and one's just generic. We have an Ethernet solution, so you can do standard Ethernet or power over Ethernet solutions to actually power the board over PoE. And then the last solution, something new we've done recently in collaboration with Blues Wireless here in the United States, that brings their note card, which is a cellular card, into this function board system. You'll notice a lot of these are communication protocols or technologies that we can mix and match to give different capabilities to the prototyping solution our customers are trying to achieve. So we have the MicroMod ecosystem and we have the Quick ecosystem, and that's when we build new technology in Sparkfun, we like to bring those into our ecosystems because our customers can build off solutions they currently have to bring in new technologies. And this is where we bring in single pair Ethernet. This was a partnership we've done with Sparkfun, Analog Devices, HARTING, DigiKey, and Worth to put a solution together last year, delivered to the market last year, based on the new single pair Ethernet technology, and bring a dev board into our ecosystems that allow our customers to rapidly develop, experiment, try single pair Ethernet in solutions that they're trying to build. And so we worked together, collaborated, discussed what were the best solutions here, and came up with a development board that fits in with our Sparkfun ecosystems. And again, this was what we call two-wire, or it became single pair Ethernet development board. It was based on a solution from Analog Devices, the IC, the ADIN1110. Connectors and cables from HARTING, so do the industry standard connectors and cables. We wanted to support Ethernet-based connectivity, single pair Ethernet-based connectivity between microprocessors and standard Ethernet deployment. So can we make a media conversion board to bridge the two networking technologies? We wanted to support a wide variety of microprocessor platforms and enable access to Sparkfun's Quick ecosystem. And it really became obvious as we discussed this, is let's make this MicroMod function board. And we did. We worked together. We released this solution to the market last year. And we have this MicroMod function board you can see on the right here. And it's based on the ADIN1110 solution IC from Analog Devices, and the connectors are from HARTING. And you can see we have a board that plugs into our MicroMod main boards. And there's a couple examples here where we have a sensor on one board, communicating over SPE, single pair Ethernet, to another board, and displaying results in a LCD display. And what's interesting here, there was no soldering required. It really was plug and play, plug the different boards together, connect to SPE, modify an example we have on the software side, and you have a demo running. And this board is available in our website and our partners' distributors, and it's really a board. And we also sell a kit. The kit's really the way to go when looking at SPE, because you get two boards, two MicroMod main boards, a cable, ESP32 processor, an Artemis processor, our Apollo 3 base processor, to allow you to get connected quickly and experiment with SPE and see how it works and how it might fit in with your solution. And as we do with all our products at Sparkfun, we also added kind of high-level, easy-to-follow documentation. So here's an example, a couple screenshots of the documentation off of our website, and something we call a hookup guide. And it gives you an overview of the board, overview of the kits, and then we can see we highlight different aspects of the board, different connectors, different mounting points. And this is really all detailed in a very easy to digest documentation page. High level, to get you started with the solution. And for those users who really want detail, they can drop down and start looking at the data sheets of the actual IC and the products. And additionally, we publish all our driver software on GitHub. So the driver for this, it's an Arduino solution. All the source code is up in our GitHub repository, all open source, all available. And this includes a lot of examples. And actually also some examples that we use for a demo, which I'll walk through shortly. But again, the goal is to really help engineers, researchers, makers, customers really understand and dig down and understand how the system works. If they see issues, they can send them our way and we'll get them corrected. But everything's there and it helps jumpstart the customer quickly. And basically, we have several videos for the solution. Sparkfun, we do a lot of videos when we launch a product, and these are up on our YouTube channel. We have an overview, and then we did a kind of a 15-minute demo video that we filmed last year. That's also up there, and talking about some pumps we have in our basement, our building's basement, which was kind of fun to do. But again, this is standard stuff we do at Sparkfun. And this also helps, reduce the barrier of entry into understanding single pair Ethernet, how it can provide a solution for you, and what software and hardware is required. And, part of what we did here with single pair Ethernet and working with our partners as a demo, I thought I'd just go over real quick at a high level and give you an idea how single pair Ethernet can be used and how we use it, actually are using it today in our Sparkfun headquarters building I showed you earlier. So one of the strange things about Sparkfun's building is we have a basement, which is, I guess, unique in the United States where we are. And there's a actual pump in the basement to prevent it from flooding. So there's a high water table. The water kind of comes kind of high. And we have these two outflow pumps and a pump. And if you go to the basement, you can open up a hatch, a door, and see the water underneath. And the pumps run about every 2 to 5 minutes. Depending on the level of water that's here in Colorado. But no one monitors these pumps, so we don't know if they're working correctly. Did they stop working? We just assume they're going to run, and we thought, well, this would be maybe a solution for monitoring it. And someone actually tried to monitor this. We found this I think when they moved to the building before my time, they put a Wi-Fi based board down there in the basement to monitor the pumps. But it never worked because there was no Wi-Fi connectivity down underneath the concrete and metal that was above this basement. So this board, we just went down there and it's just kind of hanging off the ceiling. It was just abandoned. No one ever cleaned it up. It's kind of interesting, the artifacts you'll find sometimes in basements. And we thought, well, maybe this is a solution for single pair Ethernet. And, we need a robust networking capability, something easy to route down to the basement. And it seemed like a great example of how we could use our single pair Ethernet technologies. So that's what we did for a demo last year. And this is kind of a cartoon, an overview sketch where we had sensors on those outflow pipes of the pumps to monitor the vibration of the pipes, so we can tell when the pumps are running. That data is captured and sent over single pair Ethernet to an auxiliary room in a part of the office that has access to the corporate network. That single pair Ethernet message is then converted into a standard Ethernet message and sent to a server, which kind of does business analytics of data, and can also send out alerts. And this is based on the machine chat technology, which is something we offer and partner with, as well as DigiKey. So we actually went off and implemented this is kind of some some hardware we've done before we actually installed it. But it's in the basement we have a accelerometer on the pipes and a microprocessor that monitors the acceleration. When we determine that the pump is running, we'll send a message down through single pair Ethernet to our other client, which has access to the corporate network. And this is all done using an Artemis MicroMod processor, the boards I talked about earlier, and a long single pair Ethernet cable we've fished up through a cable conduit up to the main floor out of the basement. It's something that, again, that has access to our corporate network. And we're sending data using what's called a JSON string, kind of a standard networking technology. Very easy to do. Single pair Ethernet made this very straightforward to enable. And then up in our main floor, we have an auxiliary room. And here's an example of converting from single pair Ethernet to an Ethernet solution. So this processor just monitors the input messages coming from the basement pumps. And when it detects it, it then translates that into a standard Ethernet message and sends that over HTTP to our machine chat server that we have in the building in our kind of network room. And machine chat, this is a standard off-the-shelf software, runs on a small Raspberry Pi or small PC, and it just inputs the data. It can do dashboards and plots, but also going to do alerting and let us know if there's issues, if our pumps start failing or not, or they're running too quickly. Different rules, business rules can be set up in machine chat, and it's very handy and easy to implement. It made a great solution for this demo, and actually the solution we're using today. And here's another picture, a high-level picture to kind of show how this works. We have our sensors on the left that detect if they're, the status of the pumps, sends messages through single pair Ethernet to our auxiliary room station that converts from single pair Ethernet to standard corporate network, sends that data over a PoE connection to our machine chat server, which gives us dashboards, monitoring, messaging, alerts, to really give us a great solution. And again, here, single pair Ethernet allowed us to go where it wasn't easy to have network access, or it was an area that really wasn't fit for just standard networking, something more robust. And that's what we did with single pair Ethernet today in this solution. So this was a great little demo we did. There's actually a video of it, and they had me walk through it last summer. This is up on our YouTube channel. If you really want to see what we did and how our boards work to develop a single pair Ethernet solution, I encourage you to go over there. I can't watch it because I can't watch myself talk, but it was a fun project. And also, the video shows some details about Sparkfun itself. Very curious how we work, what we do, and what we provide to our customers. So kind of in summary, and again, thank you for your time today. We have a single pair Ethernet MicroMod function board. It really provides a rapid solution to experiment, try out, and use single pair Ethernet. It's based off our partners' analog devices and HARTING connectors and connectivity, and it allows you to really assemble things quickly, grab a sensor, grab SPE solutions, develop a solution, a prototype of what you're trying to build for your specific needs, and then move that into a production solution. And with that, I want to thank you. Thank you for your time today. Appreciate you listening to this video. Sorry I couldn't be live, but it's 3 o'clock in the morning here in Colorado. And with that, I'd like to return back to Germany. And again, thank you again, and have a great day.
Thank you very much, Kirk. We will let him know your good morning then in, let's say, 3 hours when it's morning in Arizona as well. I think that was really a great use case of how is the status of the technology. So there are really the tools in place where you can start to set up your design for any application. And as Kirk said, the kit is available. You can order it via DigiKey, for example, and then really play with the technology and bring it to work.